So I want to speak to you today about loading complex salt isopachs. And this is an example here of where we're going to actually load these separated actual salt areas and actually expel them, we hope. So why would we study salt bearing rift basins? Well, if you add in salt into everything, actually either after extension or during extension, this adds an awful lot of complexity to post-depositional salt tectonics in an awful lot of ways, because salt could be absent, a cross highs such as transfer zones, horse blocks, and variable salt thickness would also impact subsequent styles of deformation, the degree of coupling, etc., during extension and possibly also during inversion. But what I want to actually aim at here is that after breakup and separation, and when the margin begins to tilt, then this extreme topography that we have, this extreme structural topography, variations in salt thickness, absence of salt in some locations would have huge implications for early stage for early stage gravity gliding and also load driven spreading.
That actually in this talk. So if we prograde over a simple salt isopack, what we end up with is just a very simple, easily understandable ex expulsion expulsion rollover system that we see on here. We expel the salt continually actually outboard. And, actually I want to use physical models to explore what happens in areas like here. These are from the Scotian margin, and we can see here two separate salt sub-basins here, and in this other example, we got four separate salt basins, and we got extremely complex salt expulsion styles, etc., as we actually end up actually outboard here. And I want to show you two different physical models that had different structural actual that had different structural architectures, and we see what
Actually, at that, let's have a look at what I do and how, and then how do we actually generate a segmented rift system. So here's a typical setup here in my lab. So we got digital SLR camera actually overhead. Then we have this stereo CCD system, digital image correlation system. And we track by adding in these spheres, unispheres, into our ordinary sand here, and you can see what happens after we add them in. So you can easily track actually everything happening on that actual upper surface. And our salt analog is, as always, a long chain silicon polymer everybody uses. And so here's an actual old one here, but these traditional rift models are formed by stretching rubber sheets. The problem is they are very cylindrical, a long strike, so there isn't an awful lot of offset, etc. We can introduce offsets into them by having separate stretching rubber sheets, but the problem with that is when you stretch something out like so, you also constrict, and that introduces an awful lot of internal artifacts within your system. So what I've ended up at is an actual hybrid system with a stretching sheet and a very thin layer of silicone over that. And then I add in these, what I call weak crustal zones. And they serve to focus in almost all of the extension that you see. And if I can just show you, here's this is the same example as here after pre-salt extension here. So we have an offset on echelon system of structures. And I just want to show the two that you're going to see today. I used slabs of varying height and low locations on here to form these actual offset rift systems, and then here a kind of mirror image here in the actual inboard to outboard through an accommodation zone here. So let's have a look at the first one from overhead before adding in the salt. So we have a small graben system, but continuous, a narrow graben that opens to the south here, and deep actual outboard graben here that actually ends down here, steps the extension steps actually inboard, and you add in the salt, and you add in salt tilted, and then prograde out. And we are also going to be adding on sediments actually outboard of our prograding wedges. Here's model 2 here with deep graben in the south that goes through this great big, pretty low relief transfer zone in, and then flips up into this other deep graben. So there's the landward limit of aggradation on it. This one here, prograding out actually on this once more. And from overhead, you don't really see an awful lot, and this goes on for a long time, 27 days. But you begin to see some salt being expelled out from the actual the systems that you see in here. So what I want to aim at are, let's just aim at styles of salt expulsion. And the first style is that the salt never makes it actually out. It's trapped actually in each graben system. And even where it was able to significantly be where you actually had significant seaward inflation, you actually were also adding on extra sediments out here, which helped to prevent it from ending up actually outboard. Then salt expelled into diapers above these actual these intermediate high blocks here. So what happens is that you expel the salt seaward, it interacts with the horse block, it contractually thickens here, and it actually ends up actually upwards because it can't spread out very far here because you've got you actually have got inflated areas out here that prevent the spreading, so you get major diapers actually in these areas. So style 3, shallow row system. So where you can expel the salt up and actually outward, you get step under regionals that just help to expel that salt. Salt is expelled up and out, and then you get shallow extension here, and the same thing happened here. You've got some trap salt in here, then you expel this stuff up, it pushes up that actual roof here, spreads out, begins to extend here, and you've got tertiary welding actually outboard. So style 4, where we have much more complex systems that were only separated by small horse blocks, so you get expulsion of the salt up and out, stacking of these salt bodies, stacked primary wells and tertiary wells, and then a canopy forms actually outboard, and once more shallow extension actually outboard of that. And then my favorite one is where you've got these great broad transfer zones, and in here I actually had added green to my salt so I could see that, and you can see that green salt has been expelled all of the way outboard, and here you can actually see it go all the way up into the shallow row system. There is some even actually outboard here. So again, shallow extension here, step counter regional. So let's just have a look at a couple of examples from the Scotian margin. So here's a seismic base line drawing here. And again, we see salt from an actual up-dip salt basin expelled up and out a shallow row system, and then a new canopy system actually outboard actually of this same that you see in this is from model 2 here. Beautiful example here, salt being expelled up and out, extend upwards. You're also adding on extra load to the underlying salt body that's expelled up and out, and they merge to form a composite actual canopy system. And ocean margin again. So just generally here, things are dominated by step counter regionals. There's very little extension that you see at the autochthonous level. All the extension that you see is shallow level ROHO, same as we see in the physical model here. Step kind of regional, salt being expelled from under that load up and out, and then shallow extension, and everything it climbs actually seaward. So just want to end with concluding remarks here. Just that segmented and separated salt basin generally, so quite limited extension and translation at the autochthonous level. And super salt style generally is dominated by step kind of regional systems, but we still see significant salt expulsion even in the absence of major salt, even in the absence of major salt budget here. Some major major horse blocks are barriers and can be sites of strong intra-rift diaparism as we spread actually out from this. And this all depends on the salt budget that you have in the system and the strength of the roof. Smaller horse can allow salt expulsion from one graben system to the others, and we can stack salt bodies with and show shallow ROHO extension and canopy formation where the salt budget is as we have here, sufficient. And similarly, portions of the rift zone with more subdued structural topography and thus better connectivity facilitate far more efficient salt expulsion. And I'll actually end it there.
Thanks a lot, Tim. We
Sure.
have time for some questions. We already had a bit of discussion going on in the chat. Maybe Gary, maybe you can ask your question so that Tim also can comment on it.
Okay.
Oh, okay. Nice presentation, Tom. Sorry, Tim.
Okay, thank you.
Sorry. I'm always concerned with these approaches where isostasine, especially flexural isostasine, is not brought into account in some way. As you try to build up these loads, flexural sort of depress the basement, making it more difficult to climb out of the depressions made by isostasine. I've seen some pretty interesting work done with the Jurassic tank where they have included isostasine, and it does significantly, it modifies in a very interesting way the stratigraphies you get and therefore the results. Would you like to comment on how you think isostasine and flexural isostasine in particular might force you to, or what might it do to your results?
Okay, firstly, I would say that every model is actually, every model is wrong actually anyways. There are some things that you can introduce in here perhaps, but to be honest with you, I cannot add that in our current setup actually anyways. As to how it would impact things, I'm sure it would have a pretty major impact in terms of where you're going to focus this sediment as it ends up in. And once more, the sediment input I actually have here is extremely simple overall. It really doesn't take into account any added structural topography that happens that happens after rifting. So my answer to you is yes, it would change an awful lot as to what things would look like. I'm kind of unsure.
It would be nice to explore that maybe theoretically at one time, but I think that was a very good response, Tim. Thanks very much.
Sure.
We have the next question by Mark. Mark, you asked it yourself?
Yes, what I was asking was, Tim, have you done any modeling where there's ongoing rifting, in other words, increasing base salt relief as you're getting super salt deformation?
I've only ended up at it just in pure expansion. So when we are still actively extending, and when we aren't at that stage that we've gone to, we aren't at the stage where we have gone to separation. There's no and there's no tilt on the in the entire system. Also, it's something that I would it's something that I actually aim to end up at. I mean, I've been ending up at this is the result of 2 years, and I think we still have another 3 or 4 years of work. Actually, 3 or 4 years of extra work actually. Because also what we need to do is also need to test structural. We also need to test structural the impact of structural style, and by that I mean, so we want to add in half graben systems and see what happens when we prograde out. See what impact for instance, a landward facing half graben versus a seaward facing half graben has.
I'll keep tuned in as always.
Okay, Mark.